Hello everyone, this is Philip from Pantech and I welcome you all for engage your learning experience with Pantech Learning anytime, anywhere and any places. We are always supporting to the students in a technical way. What is our main vision? We are going to help 10 million students to learn the technical knowledge by the easy way. And I welcome you all to today's session of Artificial Intelligence Masterclass. Today we are going to discussing about one of the interesting topic in computer vision, that is face mask detection. So this particular topic is very important for detecting the masked person. Okay, so how to do that? So we having the following the two different procedure for training as well as the testing. So how to training the model with the help of the past data, that means the digital images wearing the mask and without mask, with mask and without mask, we are going to using the different kind of the data test to training the model. Okay, by using the convolution neural network. These are the things we are going to discuss. So without delay, I'm going to enter into today's topic. In this particular session, we are going to discussing about the how to training the model and how to testing the model, and you can accessing these particular session. We are going to discussing about the real time face mask detection. We are going to discuss how to do that. So without delay, I'm going to enter in the topic. First, the introduction of face mask detection. During the pandemic time of COVID-19, the WHO, that is WHO, has made wearing the face mask, compulsory to protect the against the deadly virus, right? So that time we are facing these kind of the things every day. So without wearing the mask, they can't allow, and without wearing the mask, they can't allow. So the mask is compulsory. So wearing the mask is compulsory. So what is the contribution of the artificial intelligence here in the sense? We can detect the person without wearing the mask and with the wearing the mask. It can be possible for, it will be helpful for the, detecting the person while you are entering the malls or while you are entering the hospital. That time it will be more helpful for that. So with the kind of this particular system, it will be help to detect, and it will be help to that, catch that particular person without wearing the mask. Because of that time, it will be very necessary because of we have to avoiding the spreading the virus. Because of that pandemic time, we are facing the many problems. So with the help of this particular system, it will be help to finding and catching that particular person without wearing the mask. Because of that time is very necessary, right? Yeah. The global pandemic COVID-19 circumstance, it is emerged that is very dangerous. So that is the reason that particular technology we are going to build to catching that particular person. So without wearing the mask. So it will be help. Once you are wearing the mask, it will be help to prevent that particular, from that particular virus. So that's why this particular wearing the face mask will help to preventing the spread of the infection. Okay, so and preventing the individual, contrasting to the infection of the airborne like that. So once you are using this particular technology to catch that person, that time we can avoid and we can prevent from that particular virus. So we are using the face mask detection system. So we are going to follow the two different procedure, training as well as the testing. So training with the help of the CNN, convolution neural network, as well as we need a certain data set. Okay, so the data set consists of with the mask and without mask. So in this particular system, we can monitor for this face mask system. We can monitor if the people are wearing the mask or not. Okay, so here we are using the cafe model to detecting the faces. I mentioned wrongly here. So here we are using the cafe model to detecting the faces. After that only it can be possible for detecting the face mask. Okay, right. So without delay, I am going to entering. What is the objective of this particular task? We will be built a real-time system for detecting the face mask. If the person is wearing a mask or without wearing a mask, that system, the particular system, we are going to detect. So actually, we will be built the real time. Detecting the whether the person wearing the mask or without wearing the mask, while the person in front of the camera doesn't, that time the camera will detect, the computer will detect, yes, person wearing the mask or without wearing the mask. So what is our one line objective? We are going to detect if the person wearing the mask or not. Okay, right. And what is the data set we are going to use? The data set is consist of nearly 1366 images. 1366 images belongs to the two different classes. The one is the with mask and another one is the without mask. The with the mask having the 690 images and without mask 676 images. So you can see this particular data set. I will show that. Then only you can understand in an easier way. Okay. So face mask detection and just a minute. You can see the data set here. So it having the two different classes with mask and without mask. So with the mask, you can see here, it having the different images like this. With the help of this particular data set, we are going to train the model. Okay, right. You can see here, it is nearly 690 items inside the particular folder. And without mask, you can see here. So without mask, 676 items inside the folder. Okay, right. So this is it is consist of 1366 images, both the classes. Okay, right. After that, what is the program phases? Here we are going to follow the two different phases. First one, the training the model and deploying the model. So here we will focusing on loading our face mask detection data set from the disk, because of that will be more helpful to training the model. So based on the features, it will be helpful to detect the faces, face mask or without face mask, like that. So training a model by using the class, that means we are using the convolution neural network. Okay, so that is the training process. And what about the deployment? Once the face mask detector is trained, we can move to loading the new data, loading the trained model. After that, we are going to passing the new data while accessing the real-time camera or web camera. When you are going to in front of the camera, that the system will detect you are wearing a mask or without mask. With mask or without mask, that will be detected. Okay, so how to do that? In this, I will mention here, the performance of the face detection. First, it is initially going to detect the faces. After that, only entering the mask detection. Okay, so it can be possible to detect whether the person is wearing a mask or not. Okay, two different procedure we have to follow. The first one is training and second one is the deployment. Okay, right. So what is the training and what is the testing? What are the procedures we are going to follow? Okay, so I don't want to take more time for the theoretical part. I will enter in the coding session. Then only you can understand in an easier way. Okay, so what are the procedures we are going to follow? First, we are going to follow the data augmentation. That is nothing but we are going to create the argbook parser that will be help to initialize and accessing to particular path for images and model and this all other things. Okay, then loading the data set, that is very important for training the model, and pre-processing images for that particular folders, and loading the mobile net, that is the nothing but architecture of the CNN model. So that will be more helpful to creating the base model of our system. So most probably when you are going to using the Raspberry Pi or Arduino, so that's kind of the things, this particular framework will help to easier work with that. Okay, so that is the reason we have to choose the mobile net V2 classifier. After that, building a new fully connected layer. So that is nothing but the head model. So head model is normally working on the base model. Okay, then we need to compiling the model. After that, we need to training the model. Before training the model, we need to preparing the data for training the model, because of the computer is expecting the specified value for training the model. So that is the reason before training the model, we need to pre-processing all the images and normalizing all the images and converting that, and these are the things we have to follow. What about the testing? Once the model is trained, we are going to enter in the testing. That time we have to loading the model to the system. Then we have to pre-processing the new images. Then we are going to passing to the new model. That time the model will detect and the model will analyzing the new data. Then it will be predict whether the person is wearing a mask or not. Okay, right. So for initially it will be help to detecting the faces. After that we are going to enter in the mask detection. Okay, so without delay, I'm going to explain about the training process. Then we are going to enter the deployment. Okay, right. So without delay, I'm going to opening the training mask. Okay, training mask detector. So this is the procedure to training your model. So what are the procedure we are going to follow today? In the sense, the first, importing the necessary libraries. So Keras preprocess for pre-processing the images, Keras application for initializing the mobile net V2, that is the nothing but the architecture of the convolution neural network. That is, we are going to, by using the mobile net V2 will help to creating the base model of our system. Okay, then Keras layer. So we are using the average pool entity and dropout and flatten and tens and input and finally the model. So these are the layers we are going to use to training the model and building the model. Right. After that, the Keras models and importing the model. Then optimizer we are going to use to while the compiling the model. Then application for the mobile V2. So that will be help to pre-processing the input, then pre-processing image into the array and loading the images to categorical, that is with the help of the utils, and label binarization, that will be help to binarizing the image, the value between the 0 to 1 of all the images. So that we will get it from the scalar. So scalar pre-process will help to binarizing the image, that means its value will be 0 to 1. Once you converting the image into the array, that time we can converting 0 to 1 value with the help of the label binarizer. After that, the model selection to splitting the data for testing and training. So that is the helpful for preparing the data for the training the model. And the metrics, that is nothing but to create and calculate the accuracy score of that particular model. And Matplotlib will help to plotting the accuracy score and also the loss value, that is the history of the performance. And numpys and arc process is very important to initializing the path and OS. Because if we have to accessing the path, we need OS that particular package model. Okay, right. So without delay, construct the argument process to pass the argument for input data. That is nothing but the data set. Okay, for training the model and plotting. So that will be helpful for history of the performance based on the losses value as well as the accuracy value. Okay. Then arc parser for the model. So you can see here. So initialize the arc parser argument parser. Then we have to adding the parser argument parser for the data set to path the data set to path the plot, and it will be helpful for the models as well to saving the model. Okay, so these are the argument for a data set, for plot, for model. Okay, after that we are going to creating and storing the value here. After that, we are going to initializing the initial learning rating as well as the mentioning the number of approaches as well as the batch sizes. So that is the initial learning rate, that is LE minus 4, and batch size will be 20 as well as the approaches will be 20 and batch size will be 32. Now we are going to grabbing the list of the images from our dataset directory. Okay, because we are going to load the dataset. So how to do that? We are going to accessing the OS to path that list images to passing the arc of the dataset. So here you can see here. So print the information to loading the images. Now we are going to loading the images. So image path is equal to list of. So we are going to create the list of paths dot list images. Then you can call this particular arcs, then passing the data set here. So this is the value of that particular things. Okay, this is the folder name of our data set. Then we are going to initializing the empty list for the data as well as the label. Why we are going to create? Because of once you are going to iterating over the sequence of that particular training data set, that will be going to append to store in the data as well as the label. Okay, so label in the sense what is that? The class's name. Class's name mask and without mask, like that. Then we are going to looping over the image path. So with the help of the for loop, image for this is the iterating variable and this is the sequential variable. Now we are going to extracting the class label of the each folder. So what is the label with mask and without mask. That is the label. So we are going to extracting the classes label from the file name. So that means label is equal to image path dot split then os dot path dot separate of the classes name. Okay. Now we are going to storing the value of the label. So we are going to store this particular variable. Okay. For the label name. Now loading the input images as the sizes will be 2 to 4. That is nothing but the pre-processing the input image or input loading the data set. So image is equal to load the image of the image path. So already we are assigning the value. We are assigning the value here. That means this iterating variable iterating over the sequence of each and every images inside the training path, inside the data set path. So all the images will convert to the target size will be the 2 to 4 by 2 to 4. That is the pre-processing. Then we are going to converting the image into the array format because of the computer can't understanding the real image. So we have to converting the array format. Then after that we have to pre-processing the input that particular image. Now we are going to update the data as well as the label list because of we are going to appending the pre-processing the data. So that is nothing but we are going to data dot append of the image and we are going to label dot append of the label as well. So this value we are going to append to this particular list and this value we are going to append to this particular data for each and every images inside the data set. Okay. Now we are going to converting the data label into the numpy arrays. So data is equal to np dot array of data. So the data type will be float. So normally it is an integer. It will be converted to the float. After that the label is equal to np dot array of labels. Okay. Now we are going to performing on the one-hot encoding of the label because of the computer can't understand this string. So that's why we need to converting the one-hot. The value will be zeros and ones like that. So by using the label binarizer, we are getting here you can see here label binarizer we are getting from sklearn.preprocessing. That this particular function will get it from there. So you can see here. So initialize that the label binarizer. The label, so we have to convert that particular string into the number. That is a one-hot and the value will be 0 or 1. So that means label is equal to lp dot fit transform. The string is converted of this particular label. Okay. Then it will be categorized. 0 or 1. Okay. So two category will help to categorize. And this fit transform will convert it string into the one-hot format. Okay. After that, we are going to splitting the data. We are going to splitting the data for the training purpose of the model. So partitioning the data into the training as well as the testing by splitting the 80% of the testing, 20% of the training. We are going to assigning the value of the test size parameter that is 0.2. So you can see here train X and train test X and train Y and also the test Y is equal to. So how to split the data? So already we learned in the machine learning. So with the help of the sklearn.model selection, import the test train split. So that particular data preparing the data for training the model. So that is the reason we are going to split the data for testing and training. That is nothing but training and also the validation purpose. So trains test split of the data as well as the label, then the test size will be the 0.2. Then this is the random state. So already we know that randomly selected the data. So that is 42. Now we are going to construct the data that is nothing but the training data image generated for the data augmentation. Because already we initialize the data augmentation. So because of we need to generate the images. So augmented is equal to image data generator. So we are going to pre-process the image again. Okay, so rotation range 20, zoom range 0.15, and width shift range 0.2, and height shift range 0.2, and horizontal flip and flip mode is near us. So this is the, like constructing the training images generated for the data augmentation. Now we are going to create the base model, with the help of loading the mobile network VT. So that is nothing but the architecture of CNN model creation. So here you can see here base model is equal to mobile net v2. So we having pre-trained image net. So that will be help. So that is the weight is equal to image net. Okay, image net. Then the image shape will be 2 to 4 and 2 to 4, the 3 channel. Okay, that's why we mentioned here. So once you're creating the base model, now we are going to converting the fully connected layer, that is nothing but the head model. So basically the head model is working on the base model. So why it is nothing but in the sense that is the architecture of the model, that is mobile net v2 is the architecture of the model. So head model is equal to base model dot output. So now we are going to adding the layers of the head model. So average pooling 2D, the pool size will be 7 by 7 of the head model. Then flattening, then tensing and dropwood. Then finally the tense. This is the binary classification. So that is the reason we mentioned the two different outputs. So two different output will be like this. The activation will be the softmax of the head model. Now building the model. How to do that? So place the head fully connected model on the top of the base model, because of the head model is working on the base model. So how to do that? The model is equal to model of input base model dot input and output is the head model. Okay, right. So now we are going to looping over all the layers in the base model and freeze them. They will updating during the training process. So layers in the base model dot layer. So it will be, the layers will be trainable. The layers will be trainable iterating over that. After building the model, we are going to enter the compiling the model, because of the compilation is very important for convolution neural network. So that means OPT. So that is the optimizer we are going to initialize here. The atoms of learning rate LE 0 minus 4. Then this is the divided by the approaches. So now we are going to compiling the model. The model dot compile of the loss. Three different parameters will be there, loss and optimizer and matrices. So loss is already we knew that because of it is a classification problem. So that is the reason binary cross entropy. After that, the optimizer is the opt. So already we created, that is the user defined. Then matrices is equal to accuracy. Okay. After compiling the model, we are going to enter in the training of the model. So augmented dot flow of the training data set and the batch size will be 20. Then the approaches training divided by the batch size. Then validation data, that is test X and test Y. The length of the steps will be divided by the batch size. Finally, the approaches will be 20. Okay. After, training the model, we have to save this particular model. So that means before saving the model, we are going to enter the prediction. So prediction is equal to np.argmax of the prediction IDX. So already you can see here the model dot predict of the test and the batch size. So test X. Then we are going to compare. Okay, for the prediction. Then finally it will be giving the result. So after that we are going to saving the model dot save. The extension will be h file. Okay, so this will be plot for the losses and also the accuracy. This is nothing but the history of the performance of the model, based on the loss and based on the accuracy. You can see here testing losses and testing losses and accuracy and accuracy. This is value accuracy and this is the value accuracy for the label and also the performance. Okay. So once you run this in the sense, it will be saved this particular model you can see here. See this is the model. Once you run this in the sense, this will be getting model detector dot model. This is the, our model. Okay. After that, we are going to enter the testing purpose. The training is completed. The training is completed. Now I am going to enter to explain about the detection. So this is nothing but the real time face mask detection. I am going to create that and build that. So how to do that? In the sense, first we have to initialize all the import necessary libraries. So tensor data applications of the mobile net and pre-processing the images and models is equal to load model, because of that particular function is very necessary to loading the our trained model. Then video streaming. So that will be, we are getting from the IM utils dot video and importing the video stream, and numpy, argparser, imutil, time, and cv2 and os. So these are all the libraries we have to import. Now we are going to creating the user defined function. The function name is detect and predict the model. So we having the three parameters here, that is frame and face mask and mask. So this is nothing but accessing the frame, and this is nothing but the face detector, and this is nothing but the mask detector. So we have to loading the value, passing the value for frame, for face net and mask net. Then only it will be run this particular program inside the function. So how to do that? So initially it will be going to calculate the height and width of the frame. After that, that particular frame will go to plot from the images. So what is that exactly? In the sense, we are going to converting the images into the format of the 0 to 1 format. That means normalizing the image. Normalizing the image. So the particular plot from images, it will be deals with the pixels. So that means 0 to 255 will converting into the 0 to 1 format. That is nothing but all the images. So that is nothing but we are going to converting the range between the 0 to 1. So why we are going to convert this? And that will be more helpful for the confidence value. So based on the confidence value, it will be returning the output. So we have to convert the plot for all the images. Okay. So this is mean square root you have to calculate, and this is the size of the images. So these are the things we have to passing. After calculate the plot, we are going to enter to detecting the faces. So that is the reason face net dot set input for the plot. Because of all the plot of the every images, it will be help to finding the detecting the face with the help of the face net. So detection is equal to face net dot forward this plot. Yeah, we are going to storing the block value to the face net. Then the face net we are going to passing through the forwarded to the face net this particular value. Now, so this is the sequential for detection. Now we are going to initialize the list of the faces and also the corresponding location and also the prediction. Because of face detection is based on the locating the face. So that is the reason the list of the faces and list of the location and list of the prediction. Okay. And now we are going to looping over the detection. So that is nothing but sequence detected faces. So I is nothing but a iterating variable. The range between the 0 to the detection phases of the while accessing the camera. That time we are going to extracting the confidence associated with the detection. Okay, so already I said to you, we are converting the log from the image. Okay, that log, the range will be 0 to 1. So based on the probability value of each and every images, the face detection, it will be finding the output. So the confidence value of the detections, it will be returning the certain value in between the 0 to 1. So once the probability is nothing but wear mask or without wear mask, based on the confidence value. Normally the threshold, based on the threshold value, it will be assigning the output. For example, 0.5 in between the 0 to 1, 0.5 will be the threshold value. So 0.8 is in the sense that is tends to 1. So tends to 1 in the sense with the mask. 0 in the sense without mask. Like that only we can predict. So the filter out the making detections. So based on the confidence value, filter out the making detection. That will be help to removing the unwanted features from the image. So if the confidence value in greater than Greater than arc in the sense that is like, detected output, detected phases. So we have to create the bounding boxes of that particular detection phases. So we have to calculate the coordinates and coordinates of that particular, detected phases. Then ensuring the bounding box of the, the dimensions of the frame. So start X and start Y and end X and end Y. This will be helpful for creating the bounding box of that. Now we are going to extracting the phase region of interest to converting, that is nothing but a pre-process it. Okay, pre-process it. Why? Because of when you are going to passing the detected phases to the mask, that is expecting the pre-processed image. Because of we trained like this. So that's why we need to converting into that the phase of face mask. Okay, phase of face mask. Then we are going to converting the color into the BGR into the RPG. Then resizing like 22 to 4 by 2 to 4. Then converting into the image into the array. Because of we trained like this. So that is the reason we have to convert and pre-processing it and expanding the dimension. Now we are going to adding and bounding boxes of their respective list. So this is location. That is the bounding box. That means once the base is detected, this is the location. This is the location of detecting the phases. So phase dot append of the phases, then location dot append of the starting X, starting Y, and end X, end Y. So that is nothing but starting coordinate and end coordinate based on the width and height. That is the end. Okay. After that, here. So only make the prediction if least one phase was detected. So for example, if the length of the phase is greater than 0, okay, greater than 0 in the sense predict the phases. Okay, now we are going to initialize and call that mask net to predict that particular phase value. So that's why I mentioned here. Okay, right. So phases. Now we are going to initialize the arc parser, argument parser. Then we are going to loading the phase mask detector from the disk. This is nothing but user defined function. Once you call this in the sense, it will be run. We have to pass the value to here. So now we are going to initialize and store the value for this particular argument and parameter. Okay. Now we are going to calculate the store the argument for that particular parameter. So initialize and construct the argument parser for the parse arguments. So this is for the phase detection and model loading, and this is the confidence value. Okay, then we are going to we have to initialize that particular trained model for the phase detector. What is that exactly? You can see here. Yeah, just a minute, guys. I open the folder. I open the folder phase mask detection, and you can see here. You can see here. This is the phase detector. So this is the pre-trained model. Pre-trained model. So this is the proto-text file. This is the KEFI model. So if you're using the KEFI pre-trained model in the sense, we need a network. We need a base. So because of the KEFI model is working with the help of the proto-text. So that is the reason we need two different files to loading the network as well as the pre-trained model. So proto-path to os.path separate to join that particular argument parser of the phase to the product file as well as the same thing for the wait path. Why we are going to initialize this particular argument parser? Because of we have to initialize to to the path for that the pre-trained model of the phase detector. After that, loading the phase mask detected model from the disk because of which we trained our model. So already we knew this. We trained already. So mask net is equal to loading the model to argument parser of the model. So that is the folder you can see here. So folder you can see here. Yeah, just a minute. You can see here. So this is this particular model we are going to load that. After that, we are going to initialize the video stream and allow the camera sensor to warm up. So Bias is equal to video stream. Here I mentioned the camera ID 1 because of I'm using the two different camera. If you are not using the two different camera, you have to mention 0. Then now we are going to iterating, looping for that particular frame. So while true. Looping over the frame of the video stream. So frame is equal to video stream dot read. So which we created. Then resizing the frame. Then the coloring like 0 to 55 to 55. Then put the text like that particular frame like COVID-19. Okay, COVID-19 face mask detector of the name. Once you creating the initializing the frame, that time the text will be come here. Then, so this is the font style. Okay, this is the font style and this is the color. So that which we initialized here, and this will be the thickness of the text. Now we are going to calculate the box, and this will be like predict. So what is that exactly meaning of that? In the sense, box is nothing but a counting box while the face is detected. Okay, then predicts is that the mask mask with mask or without mask, that is the prediction. So looping over the location, that predict, because of we already predicted here of the where predicted is nothing but the detected faces. You can see here, if the face is detected, we are initializing the mask net dot predictor faces. So that means the result. Okay, result. So we are going to iterating over the face mask detector as well as the face detector to draw the bounding box and for the prediction. So we are going to iterating over that. We can get it from the value depend on the location. For this value, we can get it from the prediction, like mask and with mask and without mask. Now we are going to reading over that. So we have to calculate that x coordinate, y coordinate, and also the index and the into y for the box. And the mask with mask and without mask, that is the prediction. So the label is equal to face mask. If the mask without in the sense, else the no mask. Okay. Then the color will be like, so here we are going to initialize the color of that. For example, if face masked in the sense, the color will be like, green. Because of PGR, we mentioned like, 250. That is face masked. Otherwise, it will be like, red. That is, no face mask. So the label will be like, the format of the mask and without mask. Then the put the text on that particular, detected faces. Then the frame and label. So we have to mention here with mask and without mask. The coordinate like this. So minus 10 to return that particular text. So this is the style of the written text, and this is the thickness and color. Okay. Now we are going to cv2 dot rectangle on that particular frame. Now cv2 dot im show to that particular frame, it will be displaced. Once you click Q in the sense, that time the looping will be terminated. Now I'm going to run this. You can see the output for this. Okay, right. So this will be very cool output actually. Try to understanding this one. Now I'm going to run this. It is going to load the face mask detector and face detector, face mask detector, and starting the video stream. The output will be like, the face mask. Okay, no face mask here mentioned. No face mask. The value will be nearly 100% because of I'm not wearing the face mask. The display like, COVID-19 face mask because of the green and red mixed color, that is will be displayed like, yellow. And it will be, creating the bounding box based on the length, width, and height. Okay. After that, if I'm going to wear a mask, it will be changed like this. It will be changed like this. Yeah. You can see here the face masked. The face masked right now. Okay. It is nearly 95 to 92 and 96%. That is the probability value. The probabilistical value of the face masked. Okay. It will be displayed like this. Once I unwear this one, automatically it is moved to the red color. There is a notification like, no face mask. If I wear it again, you can see the output for this. Right? Clear now? So this is nothing but face mask detector in real time. Hope you guys are understood about this. This is nothing but the face mask detector real-time system. Real-time system. If I click Q in the sense, it will be going to terminate and close this one. Hope you guys are understood about this. Once again, I will run this. You can see the output. Now I'm wearing the face mask right now. Now I'm wearing the face mask and it is going to loading the face detector and face mask detector. Just a minute, guys. Yeah, some kind of the error will come because of I will now I'm going to like once again I will open and run this. You can see the output for this video detector and run this again, close this and open it again. File open and video detector. Then going to run this. You can see the output for this. Yeah, it is getting some error because of like the frame is, the camera is not working, I think so. Yeah, just a minute. Where is the problem actually? Just a minute. Okay, we'll try it again. Okay, so already you had seen an output, right? So some kind of the error will come. I don't know. Sometimes it will be, getting like this. You can see that. Yeah. Okay, guys. So this is the output for the face mask detector. Hope you guys are understood about this. Okay, right. Hey, are you interested to learning about the artificial intelligence technology more? Are you interested in doing the internship on artificial intelligence technology? And this is a right time to do the artificial intelligence technology internship program. And this is a special opportunity only for the artificial intelligence masterclass participants. You can join as an internship user right now. So we are giving this special offer for you guys. So maybe you are asking the question to me about the quality. If I pay the money, what about the quality? For the quality assurance, I will assure you that because of the quality is very good. If you are paying the money, definitely you will be satisfied about this. Okay, so what is the benefit of this particular internship program? That is the most important thing, right? So that I will discuss with you. So in most commonly, you are expecting what are the concepts we are going to cover in this particular artificial intelligence internship program. So in this particular artificial intelligence internship program, we are going to cover all the artificial intelligence subset of technologies. For example, what is machine learning and what is a project, how to build a project in machine learning technology. What is NLP? How to build a project in NLP technology. What is like the computer vision? How to build a project in computer vision and also with a deep learning. What is deep learning? How to build a project in deep learning technology. These all are the things I'm going to cover in this particular artificial intelligence internship program. You will be learn more about artificial intelligence technology and I'm going to cover all the concepts in artificial intelligence technology. Okay, so you who all are interested to joining this particular internship program in the sense enroll right now. The link is mentioned in the description and also the link is mentioned in the comment box. So what is the benefit? 30 days live session is accessible for the participant and also the internship user. And recorded videos is accessible for the 90 days only for the internship user. And you can receive the hands-on experience for like the building and also the developing a AI project nearly like the 10 plus projects you can receive and you can receive the source code for that particular like the project and also the reports and also the documentation for all the projects you can receive that and 30 days of downloaded presentation you can receive that. If you are an internship user means you can receive 30 days of downloaded presentation you can receive that. And every Saturday I will be available only for the internship user. That is like that completely related to the question and answer session in Zoom platform. So we are going to conduct the hackathon classes only for the internship user. If you have any queries related to which you learned before, I will answer for your queries definitely. And I will be available every Saturday for the hackathon classes who are joining this particular internship program. So that is completely related to the doubt clarification session and also the question and answer session as well. And so I will be always available. I will be support you in queries as well. Okay. And also you can reach the confirmation letter, which is get it from Pantech learning, certificate, which is get it from Pantech learning. These all are the the important, these all are the benefit of the internship user. And also the major importance is we are going to cover machine learning technology, deep learning technology, NLP technology, computer vision technology, and how to build a project in these all are the technologies in artificial intelligence technology. So these are the concepts I am going to cover in this artificial intelligence internship program. If you are interested, to join immediately and enroll now immediately. So you are asking the question about the quality. Of course, the quality is very good for this much of money. Please to join the internship who all are interested to joining this artificial intelligence internship program. Please enroll right now. Okay, please enroll right now. So how to enroll this? How to enroll this? Normally we charge nearly 2000 rupees. Normally we charge nearly 2000 rupees. But only for the the masterclass participants, we are giving nearly 800 rupees. So use the coupon code AIMC4. Use the coupon code AIMC4. The discounted fee will be nearly 800 rupees. The discounted fee will be nearly 800 rupees. So for this much of money, we are giving this much of content. So normally we spend the money for packet money. So for the entertainment as well, for learning purpose, you can also spend this much of money as well. The link is mentioned in the description. The link is mentioned in the command box as well. Please enroll right now. Please enroll right now who all are interested to join the internship on artificial intelligence technology. Normally, we charge nearly 2000 rupees. For the masterclass participants, we are giving nearly 800 rupees. So use the coupon code AIMC4. The discounted fee will be nearly 800 rupees. So what are the projects I am going to discuss with you? So how to create a model and how to create the training and also the evaluation, the various machine learning model and weight prediction based on the height and also the gender, sentiment analysis using the NLP, AI virtual assistant using the Python, and also the leaf disease detection using the deep learning, character recognition using the convolution neural network, fingerprint authentication, and also the number plate recognition, age and gender detection, brain tumor detection, face mask recognition, hand gesture detection, and emotion recognition through the facial expression. These all are the projects you can receive the hands-on experience in real time, and also you can learn more about this particular project, how to create a model and how to train a model. These all are the things. Okay, so please do join immediately. This is a special offer only for the artificial intelligence masterclass participant. Enroll now. The link is mentioned in the description and also the link is mentioned in the command box. Please enroll right now and use the coupon code AIMC4. AIMC4 and you can receive the discounted fee will be nearly 800 rupees. Enroll now and learn more about the artificial intelligence technology. Okay, right. So you can also try it yourself. You can also try it yourself. So this will be most interesting face mask detector. Okay, face mask detector. Definitely it will be working on your system as well. Okay, so try it yourself and make the folder for this particular project and place all the code inside that particular folder and run it. So if you're getting error, some related module error in the sense you have to install in the command prompt. Then you can run it again. It will be definitely working. Okay. Thank you so much. Thank you so much for your listening and explore your knowledge with us. Explore your knowledge with us anytime, anywhere, and any places. We are always here for you to support you in a technical way. Okay. Right. So thank you so much. We'll see you tomorrow with a different topic. Bye bye.